Welcome to Algebra 1. We are going to be using notebooks this year. So this first set is chapter 1, 2, and 3. And just make sure you have your first and last name on it somewhere. You could doodle and decorate the front as you please. The next page that you'll find is the frequently asked questions. So hopefully if you do have a question, I would check here first. It may save you a trip from coming to see me for extra help before or after school if these are one of your questions that you may have throughout the year. Next page after is our table of contents. We have our goal planner and it will tell us what page it is on. So if I was looking for lesson 3.1 about functions, I could turn and straight to page 63 and get there. The next page after that is our goal planner. I want you to set a goal for math class for these 3 chapters, chapter 1, 2, and 3, since this is our notebook. When we have our next notebook with the other chapters 4, 5, and 11, we're going to skip a little bit there. We'll have another goal planner page for that. So just make sure you're writing your date. Today's date is 8/16/2024. Once we get to the end of this book, we'll fill in that achieved by date. And so your goal is for you in math over these chapters. And it could be stuff like take notes every day, do 10 minutes of math homework every day. Or they could be more specific, like I want to score an A on all of my tests for these 3 chapters. Okay? Or whatever your personal goal is. If it's just hey, you miss a lot of notes and you don't do homeworks, then I would focus on something like that for your goal for this first one. If math is pretty easy, then I would try and challenge yourself working on those A's, or even a goal of I'm going to come in and correct every single quiz, or I'm going to retake every test if it's below a certain grade that I set for myself, okay? And these are action steps. It doesn't have to be 5. It could be 1 or 2. It could be more. Motivation. Why are you choosing this goal? If you don't know your motivation, it's going to be really hard to stick to your goal and to achieve it by the end of this book. So make sure you have a reason why. You got to know your why. It'll motivate you a little bit more and help you achieve that goal easier, and you'll feel success. Strategy goes here. The achieve and the reflection, those are for at the end, just like the date to achieve. So we'll do those last at the end of this chapter booklet. We'll see if we achieved it. If we didn't, then we set the same goal or we alter it for next chapter, and we see and reevaluate our action steps to make sure that we can achieve it the next time. Reflection on how you feel about it. Are you feel proud? Are you a little frustrated? You know, those are the things that are going to go in there after we get through these 3 chapters. Next page is our grade tracker. So in these chapters, we have a quiz for chapter 1 and a test, a quiz for chapter 2 and a test, and then we split up chapter 3 because it's kind of big, all right? So we split it into a first half and a second half. So the first half will have a quiz and a test, and then the second half will have a quiz and a test. And you're going to keep track of your grades here. And then also keep track if you correct or retake it. What was that grade? And then any comments. I overslept, I didn't eat breakfast, or I ate breakfast, I slept really well, I had a good study group, I did all my homeworks, or I didn't do all my homeworks, I was sick that week, things like that. Put little notes or comments for you to help you see a pattern or a trend maybe in your grades. And then ways to be successful. Take good notes, watch the lessons, do your homework daily, attend extra help, correct quizzes, do corrections, and retake tests, and then a little bit more. So those are there for you guys to use and reflect throughout the chapters. And we have our first chapter today. Every chapter will start with a title. Okay, this is lesson 1.1, day 1. That will match the homework as well on Big Ideas. And our title today is Solving One-Step Linear Equations. Our objective, what we're going to be able to do is write and solve one-step linear equations by the end of this section. We're going to have a second day on it as well, so that'll have the same objective because we're reaching that same goal. We have some vocabulary here. Equation is a statement that 2 expressions are equal. For example, 2x equals 12 is an equation. Linear equation. Equation in one variable that can be written as ax plus b equals 0. A and b are constants, and a cannot be 0. Well, the word constants, I probably, just in case, we'll define that one. Constants are numbers. So it could be a whole number, fraction, decimal, positive, negative, okay? A and b are simply numbers, okay? X is the only thing that we don't know here. Now, they also said that a can't be 0. Here's the reason why. Right here, ax means a times x. If a is 0, well, 0 times x would mean that we had no x's. And then it breaks that we have this linear equation because we need at least one variable. And so it would be impossible for us to just have a number and no x there. So here's an example. 5x plus 3 equals 0. That would be an example of a linear equation. Equivalent equations. Equations that have the same solutions. So, for example, 2x minus 8 equals 0 has the same solution as 2x equals 8. The solution for x, okay, is saying if you replace x with the same exact number, these guys would both be true. So, for example, the solution for this guy I know is 4. Well, 2 times 4 minus 8. Well, 2 times 4 is 8, and 8 minus 8 is 0. So that's one solution for this guy. This guy also has 4 as a solution. 2 times 4, yes, that does equal 8. So they are equivalent equations because they have the same solution. Properties of equality. Addition, subtraction, substitution. So addition says that if you have A and B equal to each other, imagine they're on a scale, okay? Don't mind my drawing. This is a scale, okay? You have to keep them balanced by adding always the same exact amount. So if I add C to the A side, then I have to add C to the B side as well. If I don't, then my scale will look like this and be tilted where I have one side way lower than the other, okay? And that's not going to work. It always needs to be this balanced scale. Subtraction's the same thing. If I take away something from one side of my equal sign, well, now I just made that side lighter. I have to take away that same exact amount on the other side of the equal sign to make them balanced again. Substitution says that, hey, if these two are equal, then you can substitute A for B or B for A. So I can interchange them because they are the same. They just look different. For these guys, a lot of these examples are going to ask you to solve each equation and show each step and check your solution. The reason why I need you to show each step, even if it's a simple step, and I need you to check your solution, even if you know it's correct, is that we're not only learning math here, but we're learning how to write our steps out because our future classes, geometry and algebra 2, and more complex problems later on in algebra 1, require multiple steps. And sometimes we get lost in it. And we can easily make mistakes when we skip over or we don't write something out. Also, it'll take you more time to get help because then you have to explain to me again what you already did. If you have it written out, I can simply look at what you have written. We can find the mistake together because guarantee most of the time if you write it out, you'll be able to find your own mistake. It's only when you don't write something out or you really have a misunderstanding that you need somebody else to help point it out, which I can do, but it takes a lot less time if you already have the work written out the first time. So that is my goal for everybody here, is to show your work. For this first guy, we have x minus 3 equals negative 5. When I'm talking about sides, I'm talking about the different sides of our equal sign. There's always an equal sign in our equations, and there's always a left and a right side, okay? So when I am talking about the left side or the right side or the other side, that's what I'm referencing, okay? So So this first one, to solve, the only thing we don't know is this variable. And so we want to isolate it. We want to get it by itself. The only way to do that is to get rid of this -3. So we need to undo it. Undoing a subtraction requires adding, because I want to be able to get this guy to 0. -3 plus 3 gets me 0. I'm not going to write x plus 0, though. I'm just going to cross it out and write x. I still bring down my equal sign. Now, that left side, I added 3. Well, I need to balance it out and add 3 on the right side now. -5 plus 3 gives me -2. So now, to check, all we have to do is replace that x with -2. That's our substitution rule we talked about. If x is equal to -2, that means that I can replace any of my x's with this number because it is essentially the same. So -2 minus 3 equals -5. And all I have to do really with the check is, hey, is this a true statement? Does this actually equal -5? In this case, it does. Sometimes you may get a false statement. That is your red flag to go back and check to see what happened. There's a mistake somewhere. This check points it out to you that it exists. It doesn't help you find it, but it tells you it exists, and you need to go back and look it over. Next one, we have our y plus 2.8, so we're going to subtract 2.8. Again, keeping that scale balanced. I'm doing it on both sides. When we subtract 0.9 minus 2.8, we get -1.9. And remember, this cancels out to 0, but I don't have to write y plus 0. It's just y. And again, I'm going to plug in 0.9 equals, I'm going to replace that y with the number it equals, which is -1.9, and then I add 2.8. And I ask, and I check, and I do the calculation. Does this equal 0.9? Is this true? And again, we're good, and it does equal, and it's true. One more with fractions. Fractions work the same exact way as whole numbers and decimals. So I have g minus 1/3 equals -2/3, and so we're going to add 1/3 to both sides. Again, these cancel out to 0. That is our purpose. That's our goal. And then -2/3 plus 1/3 gives us -1/3. We plug in for a check. We replace the g with -1/3. We still have minus 1/3 equals -2/3. Oh, there we go, sorry. And when we're adding or subtracting fractions, we need to make sure the denominators are the same. Once they're the same, they'll stay the same. And so the calculation just really happens above. -1 minus 1 is -2. And so that is true. You can also use your calculator to help you with these calculations if you need to. If you're unsure how to use some of the buttons, just come see me. We're going to skip 4, 5, and 6 for now, all right? And I want to jump down to the properties of equality that use multiplication and division. These are paired together because they undo each other as well, all right? Multiplication will undo division, division will undo multiplication. And they work the same way as adding and subtracting when it comes to equality. If I multiply one side with a number, I need to multiply it with the same exact number. Now, with our definition, we're saying, hey, your C can't be 0, because if we pick 0 to multiply by, then it just makes everything 0, and we're not able to solve. It's not helpful. Same with division. If I'm dividing by a number, well, if you try and divide by 0, you're going to get an error. There's a domain error. We can't divide by 0. So you could pick any number to divide or multiply by as long as it's not 0. And the way we pick it is, well, what's happening with the variable. That's how we choose. So in number 7, we're going to look at this guy. We have -n divided by 5 equals -3. Now, with your negative signs, you can have your negative sign up here with your n and read it as -n divided by 5, or you can have that negative down below as well and read it as n divided by -5. Or out here like it had it. So sometimes you'll see that negative in multiple locations. Now, I'm moving it down to my number because it's going to actually give me my answer in 1 step versus 2 steps. This is not the only way to do it. If you're used to keeping your negative up top, totally fine. Continue with that. Just because it's a different way doesn't mean it's wrong. As long as it follows your mathematical rules, you can do it that way. And the way your brain works is the way you should start solving your problems, okay? Just because mine works different doesn't mean we're not going to both arrive at the same answer. Sometimes it's easier with different methods, and I'll help you along with that, but it's not just one method works better all the time. No, okay? So for this, I do choose to put my negative with my 5. The reason why is because now I'm going to undo that division by multiplying by -5. And I have to do it to both sides. Now, I'm going to cross this -5 out with this -5, but it's not because it equals 0 like before with addition and subtraction. When you have, I'm going to do a little side note over here. When you have -5 being divided by itself, anything divided by itself just equals 1. And in the past, we've learned that, well, if I have 1n, I can simply write it as just n. And that's why I cross those out. It's not that they're 0. They are 1, but we still don't write it, okay? And then on this side, 2 negatives will give you a positive. So we'll get n equals positive 15. And then again, we just check. We're going to plug into the original. And wherever I had my n, I'm going to substitute that 15 in. And so 15 divided by 5, -15 divided by 5 does in fact equal -3. And so that is true. We're good to go. We did not make an error. Again, if this is false for any reason, we got to go back up and check our work. Next one here, we have 1.3x equals 5.2. Remember that when you have numbers and variables right next to each other, this means we are multiplying. Multiply, okay? So it's really like having a dot in between, but they actually don't put a dot. They just put the number and the letter next to each other. Since this is multiplication, the only way we can undo it is by dividing by 1.3. And dividing, I represent it like a fraction in this case, all right? But that straight line across does mean division. So if you need to write that in, divide, okay? That's what this fraction bar means. We've learned that in the past, but just in case you need a refresher, you may want to jot that down. And again, 1.3 divided by 1.3 cancels out, leaving just 1x, but we just write x. And then 5.2 divided by 1.3 gives us 4. We're going to plug that in. 1.3 times 4 equals 5.2. Now, the way I wrote it, this is the way I've been writing all of my substitutions. But there's an issue here. This looks weird now. Before, I had no issue, okay? But I know for a fact that up here, it's supposed to be multiplying. Down here, it doesn't look like multiplying unless I add a dot or a set of parentheses. So sometimes when you have to substitute a number in for a letter, you may need to include parentheses around it to have it make sense and still match the problem from before. If we didn't have those parentheses, it looked like it was just 1.34, which was not correct. Now that we fixed it, we have 1.3 times 4, and that does in fact give us 5.2. Last one on this page that we're going to do is -2 divided by 5 times x equals 10. Like I said before, there are lots of different ways to do this. Some people like to get rid of their fraction and make it a decimal. Yes, absolutely. When it's not repeating, you can definitely make it a decimal simply by doing 2 divided by 5, okay? This really is -2 divided by 5. And you would get -0.4. And you can absolutely substitute that because that is equivalent to that fraction, right? Some people like to do reciprocals. That's my preferred way. It's a little less work, but you do have to remember how to do it. So I'm going to float my negative to the top this time, okay? So I have negative 2 divided by 5 times x equals 10. Now, again, the negative could be out here, it could be down with the 5, or it could float up. It doesn't matter where you put it. As long as you're not putting extra negatives, you're fine, okay? It had one negative, I still have one negative, I just floated it up. So to get rid of a fraction, I can actually multiply by the reciprocal, which is just the flipped version of the fraction. And here's why. I'm going to highlight. When I have these guys, a negative 2 in the numerator times another negative 2 but being divided in the denominator, and same thing with the 5s. There's a 5 in the numerator, 5 in the denominator, and multiplication is happening. These actually cancel out. It's as if you're writing it like this. 5 times negative 2. Well, actually, I might just do it. What's 5 times negative 2? That's negative 10. What's negative 2 times 5? That's negative 10. And we already discussed that anything divided by itself is still 1. And so this is why multiplying by the reciprocal will cancel the whole thing out. Now, I have to stay balanced. And so on the other side, I need to multiply by that same exact 5 over negative 2. 5 over negative 2. The left side has x, and this guy gets multiplied out. 10 times 5 is 50, divided by negative 2 gives me negative 25. If you convert it to a decimal and divide your 10 by negative 0.4, you will get the same exact answer. It's just a different method. It is not wrong, though. And then the last thing, let's just check it. Make sure we're good. We have negative 2 over 5. X was negative 25 equals 10. Again, this kind of looks weird. It looks like minus 25. So make sure you throw around those parentheses because we know from the original one, we're not subtracting x, we are multiplying it. But that negative made it look like minus. So make sure you're using your parentheses when you need to. And we check this. Negative 2 times negative 25 is negative 50, or sorry, positive 50, divided by 5 is 10. And so that guy wound up being true, and we are good to go. I'm going to jump to number 11. It always looks scary when we don't have a lot of numbers and we have more symbols. Number 11 is just like any other. Not scary at all. We have pi times x equals negative 2 pi. Well, treat it exactly like a number. Pi is simply a number. It goes on forever. It is, I can read you a few, 3.14159266535, and so on and so on and so on. I have a little fun thing that I'm reading off of. Don't worry, I did not memorize that. But it goes on forever. That's why they have a symbol, because it gets messy if you have so many numbers going on forever. That's hard to do. So we're going to treat it like a number. If that was the number 5 being multiplied by x, we would be dividing it. So guess what? Just because it's pi doesn't change our process. And just like the other ones, if I had 10 divided by 10 before and that gave me 1, guess what? Pi divided by pi also gives me 1. So I have 1x left. Over here, pi divided by pi gives me 1. Well, then I have negative 2 times 1. Well, that still doesn't change it. It's still just negative 2. And so we have this answer of x equals negative 2. And then we plug it in. Oops. Pi first. Pi negative 2 equals negative 2 pi. Again, this looks like minus, so throw those parentheses around it because we know from up here it's multiplication, so make sure you include them down here. And then this is true because multiplication of numbers, commutative property. It's just like saying 2 times 3 is the same as 3 times 2. We can multiply numbers in different order and it still means the same thing. That does not change just because we have pi involved. That's it for our lesson today. There's a couple other examples. You feel free to work on them, and you can check your answers. There is a homework tonight on big ideas, just like there is after every lesson. Bye.